Hello, dear people. Today we are with Lamberto Palma
Hello.
again, and we're going to be talking about
The fusion energy.
exactly.
Yeah, as you know, in the past year, many articles have been published about artificial sun and new world record in reactors, in new type of reactor, the fusion reactor. And maybe people are thinking, well, what is artificial sun? And what are they talking about? And yes, I'm here to talk that.
Excellent.
Yeah.
We'd like to hear more about artificial sun, actually.
Yeah. The artificial sun is like a human way to obtain energy, imitating the stars.
Like the sun.
Yeah, like the sun.
Okay.
And as you know, in astronomy, stars can go on with the CNO cycle. It's the carbon, nitrogen, oxygen cycle. This cycle permits to the sun to bright and also to produce heat. And that heat warm then our earth and also give us the light. So the artificial sun, the human way, imitate this cycle using hydrogen, two particles of hydrogen that I fuse each other to obtain helium and then a neutron. For rotate that, you have to raising up really high temperatures or high pressures. And if you can use the heat of this reaction for obtain electricity. That type of electricity is a green way to obtain electricity because you don't produce carbon dioxide. Oh yeah, of course there are some waste products, but I have to talk about them maybe later because I have to say something to understand better the reactor.
Okay.
And then when people know what is a fusion reactor, they will understand the wasted inside of fusion reactor. For talking about the fusion reaction, I have read some books about nuclear energy, and to explain in a simple way, also I read some articles and my books about fundamentals of physics that can say a really good general explanation about this reaction. And for the Professor Murray and Raymond Hell, they like to two nuclear particles fused together can create another particle that is lighter than the two particles. And that difference of weight is our heat, which can be used to obtain electricity. So, for obtain fusion energy, Professor Murray and Raymond say that we can do in a different ways. Bombarding targets, so hydrogen particles, with charged protons, using an accelerator, using a bomb.
For example.
Yeah. And the last one that I think is the better one is raising up the temperatures of the gas, obtain to an high enough level for obtain the fusion of the particle to create plasma and then the heat for obtain electricity. So the chemical formula about the fusion reactors are a particle of hydrogen, deuterium, and then another one that is tritium. Fused together, we obtain helium and one particle of neutron. And the neutron is the counterpart that we'll talk about when we talk about the wastage of the fusion energy. In the world, for example in China, United States and other ones, we have some different reactors, and the common one is the tokamak. The tokamak is a Russian word to explain the geometrical form of the reactor. It's like a donut. The tokamak is like a donut.
Like the donut.
Yeah, exactly. The donut.
Okay.
And we have some different tokamak in the world. The East in China, the Ether in Europe, the Mid tokamak in United States, and then a different one, the Stellator in Germany, also called Weldstein XP7. That is like a tokamak, geometrical form, but it's like a twist donut, more different than that.
Okay.
And this is one, and that are the public's reactor. But as you know, there's also some private companies that want to reach the fusion energy, and with a private way we do investments. And I think that the most valuable two of them are the Thai technology and the Helios technology. The Thai technology have a different reactors, and they want to reach 1 billion of degrees.
1 billion degrees Celsius.
1 billion degrees Celsius.
Oh,
yeah.
Okay.
With bombarding the plasma with proton charges. And then there is the Helios energy that they want to use a tokamak, but a different formula. Don't use the isotopes of hydrogen, by using hydrogen and isotopes of boron 11. And then
You talked a lot about what is fusion energy, how can we achieve it, but you didn't really tell me pros and cons. What are the downsides?
I will start with about fusion energy. And I think fusion energy is a perfect way to obtain green energy, a sort of green energy, because we have also some problems, but it's a green energy because so we don't produce carbon dioxide. That is the big problem in our Earth. And also another pro about fusion energy is that we obtain a really lot of energy in every moment. When we will able to use the fusion energy, we can do whatever we want in every place, and also don't take a lot of space for obtain that. Instead of renewable energy like solar panels or windy, they took a lot of space to obtain energy. The fusion energy is better for that, but also there are some problems. In fact, some association like the CORN and the Professor M.L. Gilbert in their articles, they talk about there are some problems in fusion energy that people don't talk about that, and also journalists don't talk about that in their articles. The first part is that there are some problems about the security of work personnel inside of nuclear central for the security, because we're raising up high temperatures and we have able to maintain that high temperatures inside of only one room and don't heat the workers inside those central. In fact, the last articles that I read, it was 2 days ago, and it was talking about that in the ITER construction site was interrupted because some association want to know about security of workers inside the central, due of we don't know how can I say if there are some problems when we work with high temperatures and the fuck with that reactors. And then the other problems that the Professor Emma Gilbert talked really good, that is when we use some materials for create the tokamak like iron or tungsten, hypothetically we have 100% of iron or tungsten melt each other, but in reality it's not that. There are some impurities inside that can be combined with the neutrons inside of the reaction and became radioactive. Of course, it's not radioactive like the nuclear fission fundamentals. We don't produce radioactive things like that, and a lot of them. But after we used the tokamak for a long period, we have to change like the walls of the tokamak, the materials, because they are too radioactive and they have a low level of radioactive that will decay until Some of them until 10 years and some of them in centuries.
It's pretty short compared to the other nuclear alternatives.
Yeah, I think so. Because it's more, we can control better the wastes of the fusion energy instead of the fission energy, and also is more safety than the other ones. Because when we have some problems, we have to use how can I say, electricity is more safety than the others, because we have to use a lot of electricity to obtain high temperatures. And when we have some problems, maybe from the electrical part, then the reaction
cannot exist.
Exactly, thank you.
You're welcome.
And so this is safety also for people. So we don't have to think that the reactor is like a bomb. It's not like a bomb, okay? It's more safety. That's enough.
Well, I still didn't understand a part.
Yeah.
Are there no wastes? How do you solve the waste problem?
So, as I said, the fusion energy produce some wastes. They are defined low-level wastes because they will decay in a small term. I cannot say, in a small term, and that is the problem. So we have to store them things and let it decay during the years. It's better than the fission energy because they are less radioactive wastes, but we have some radioactive wastes. If someone is interested about more technical parts about this argument, about the amount of wastes, the low-level energy, the chemicals reaction about the nuclear energy, we will add in the description some articles about that. And